All right, guys, welcome to our first qualitative analysis labs. This is Qual 1. And remember, with these types of labs, the question we're asking ourselves and trying to answer is blank in my solution, right? Is there something in my solution? And the ions we're going to be focused on today are going to be sodium, potassium, ammonium, silver, copper 2+, and bismuth, right? So these are the guys we're going to take a look at today. The first two in this list, sodium and potassium, we'll take a look at those two first, and this also holds true for ammonium as well. These ions are very hard to get to precipitate out. So you'll see in the most other tests, we look for precipitate, and these two, we don't. So let's take a look at what we're going to do. So for the sodium and the potassium, what we're going to take a bit of our solution. We're going to add some calcium hydroxide and some ammonium carbonate. And basically, we're just going to kind of keep it simple today. Basically, what this is going to do is going to get rid of everything but the sodium and potassium, right? It'll cause some stuff to precipitate out and get rid of it from our solution. So we'll just say get rid of all but the sodium and then the potassium. So you'll see we're going to add some calcium hydroxide and some ammonium carbonate, and then basically boil it down to a residue, add some water, that way we can work with it. And then on one side, we'll do a sodium flame test. And on the other side, a potassium flame test. So think back to Chem 101 when you learned about the quantum view of an atom and why these atoms or why these ions have different colors. So in these flame tests, basically what you do is you put your ion in a flame, and based on the color, you can tell if your ion is present or not. So you'll see in the sodium one, what we're going to be looking for is kind of a deep yellow or a deep orange flame. So something kind of like that you'll see in the video. And then the potassium one is actually one of the hardest to see. So if you try to see it when you have a solution of sodium, basically this orange is going to block out any of the color. So normally what you might see if you look up some videos, you'll see kind of like a purple lavender flame. You'll see in this lab what we're going to use is a cobalt glass. So that's going to block out this yellow flame, and it's actually going to kind of make this kind of violet flame seem kind of more red. So it's kind of a more red purple kind of color. You'll see I call it lavender in the lab, but it's more of a red color, but that'll determine your presence of potassium. All right, so first up, I got my known and my unknown right there. I'm going to put 2 mils of each into one of these evaporating dishes. All right, so let's go ahead and do that. One mil. 2 mils. One mil. 2 mils. Next up, I'm going to add some calcium hydroxide, enough to basify to litmus. Move that out of the way. So I've got my calcium hydroxide here. I'm going to add enough to basify to litmus. So I've got my red litmus paper, and it should turn blue when it's basic enough. Let's check it out. So you can see right now it shouldn't change, and it hasn't. Let's add some calcium hydroxide to this. Not really sure how much. Add some in there. Stir it up a bit. And then check the litmus paper. It looks a little bit, looks good. Turning blue. So it says to add some excess, so I'm just going to add in a little another kind of scoopish worth. And then we want to add a pinch of ammonium carbonate. So just add a tiny amount. And then repeat with the unknown. So first up, calcium hydroxide. Basic. Add a little excess. And then a pinch of ammonium carbonate. Cool. All right, next up I'm going to heat my two solutions, basically boil them down to a nice moist residue. You can see I've got my labeled known and unknown up there so I know which one's which. So let's go ahead and turn on the Bunsen burners. Cool. You can see the nice blue flame on both. So this process should go somewhat quickly. Check it out, see how it goes. Nice moist residue there. All right, you can see I let these cool down. We got a little overzealous here, but this one was a nice moist residue. Next up, we're going to add some deionized water. About 1 ml into each. A little under. There's 1 ml there. About 1 ml there. You can tell they're quite murky, so it's going to be quite hard to, the murkiness comes from solids, and so it's going to be quite hard to decant this. So I think I'll put in a test tube centrifuge, then decant. All right, so you can see off screen, I've gone ahead and centrifuged my solutions. Not perfect, but kind of good enough for now. So go ahead, kind of decant these into here. You can see it's still a little murky. We'll see if that kind of causes any issues. All right, next up is our flame test. So you can see I've got this nice inner cone, and the hottest part of the flame is going to be the tip of this inner cone. So I've got my hydrochloric acid. I'm going to take my inoculating loop, dip it in some HCl. This will help wash it off of other ions, form the salts, and burn them off essentially. And then I'm going to put it on the tip of the inner cone until like the flame is kind of colorless. And I'm going to repeat this process. So you can see the flame right now is pretty colorless. That's because I've done this off screen like 4 or 5 times, this washing. Next up, I've got my known. I'm going to take my inoculating loop and I'm going to dip it into my known. And then I'm going to put it on the flame and see if I see a bright orange flame. Let's see how this goes. You can see that's significantly brighter than the washed one. Let it cool off, and then the important thing is you really got to wash it in between trials. So again, this is the HCl. Dip it in here. Whoops, you can see I didn't let it cool enough. That's bad. And then let it burn. And you see it's still bright. So off screen, I'm going to repeat this cleaning procedure a number of times until I can go back to that clear, colorless state. All right, so off screen, I've washed this inoculating loop probably like 5 or 6 times. You can see the flame is relatively colorless again. So now we'll go ahead and ready to test our unknown. So we've got our unknown right here. Dip it in here. Whoops, you can see. Didn't let the inoculating loop cool. That's bad. And then let's dip it into our flame. So not really much of a color there. Let's wash it off and then compare it to some 0.2 molar sodium chloride. So again, dip it into some HCl. Just gonna burn all this gunk off. And now we're going to try it with some 0.2 molar sodium chloride just to give you kind of a positive test to compare it to. So dip my loop in there and let's check this out. So you can see way brighter, way brighter. That's definitely a positive right there. All right, so we got our known here. Whoops. Gonna dip the inoculating tube in here. Remember, our known should have the potassium, so we should see this lavender flame here. As you can see, a nice bright lavender flame, as would be expected. Next thing up is to wash this off with HCl a bunch of times. So let me just show you kind of one run through. So I've got some HCl right here. Dip the inoculating tube into there. And then put it back in. You can see it's still pretty lavender, so I'm going to have to go through this wash cycle quite a few times to get it to wash completely. All right, so I've washed this off a couple times. You can see when I put it back in the flame, there's still like a tiny amount of lavender there, but it's not too much. So let's go ahead and see what happens when we dip our unknown into here. So I'll take some of my unknown and then dip it in this fire for this flame test. You can see there's still a little bit of lavender, but not much of a difference from before. Nothing too bad there. Next up, let's try with a positive. So this is KCl, potassium chloride, so this obviously has potassium in it. So let's see kind of what a positive test would look like. And there again, you can see that lavender flame is very intense. So that's what a positive test looks like. So last time we tested for sodium and potassium. Next up on our list is ammonium. And similar to sodium and potassium, this is something that's very difficult to make precipitate out. So we're not going to take the, precipitate it out type of route. We're going to take some ammonia, we're going to boil it down, and then we're going to add some sodium hydroxide, some base. And so let's think about what happens when you add ammonium and some hydroxide. So if we have NH4 plus and OH minus, think about the reaction here. Here we have this kind of H plus, and here we have a hydroxide. So we have an acid and a base. And so an acid-base reaction is going to happen. And so you'll form ammonia and some H2O. And then the cool thing about this ammonia is that it's actually a gas. So it's going to start coming out of solution. And ammonia as itself is a base. So you'll see we're going to basically add some hydroxide to make the ammonium turn to ammonia, which is a gas. And then we're going to use litmus paper to tell whether it's present or not. So if it changes the color of the litmus paper, there's a base there, that's ammonia is there. If it does not change the color of the litmus paper, then ammonia is not there. All right, so off screen, I put 5 mils of our known into this 100 ml beaker, put it up here in this apparatus, and then we're going to heat it till a moist residue is left. Probably should have a little bit lower. All right, so you can see all that's kind of left. It's hard to see on camera. It's kind of this moist residue. Cool, so I got my moist residue here. To this, I'm going to add about 1 to 2 mils of water. Just going to kind of eyeball it a little bit. Looks like it should be good enough. Add 1 to 2 mils of water, and then 1 to 2 mils of 6 molar sodium hydroxide. I'm going to take a piece of litmus paper, my watch glass, moisten the litmus paper with some water. And then stick it on the kind of the convex side here. So just kind of press it on there. Cool. And then we're going to cover it up. And then we're going to gently heat and see if this piece of paper changes colors. You can see it doesn't really need heat. The change is already occurring. All right, so I'm going to put this piece of litmus paper over top of here, and you want to keep an eye on the color of the litmus paper. So I'll turn on the heat. You can tell I've increased the height between our flame so we can gently heat. So again, keep an eye on this color. You see it hasn't changed yet. Let's see what happens when we put it over the solution. Stupid glare. And you can see it's changed blue. So think about what that means. All right, so we're going to repeat with our unknown. Again, transferred 5 mils into here. So let's heat to a moist residue. As you can see, we got our nice kind of moist residue. In there, you see it's moist. It's a residue. I'm going to add some DI water to this. It's still quite hot. I was lazy. I didn't let it cool down. Should be good enough right there. And then we're going to add some of our sodium hydroxide, 1 to 2 mils. All right, so we've got our unknown set up here. Still a little bit warm. We've got our litmus paper on our watch glass. We're going to place that over top and heat gently. And then again, what you're really paying attention to is the color of this piece of litmus paper. Probably doesn't even need heat. Yeah, you can tell the reaction is quite quick. Doesn't really need to be heated. All right, last up, we've got silver, copper, and bismuth. And first off, we're going to take a look at silver. So let's see how we're going to do this. So the first thing we're going to add to this is some HCl. And really what we want here is the chloride. Silver, in the presence of chloride, will form silver chloride, which is a solid. The bismuth and the copper will not react with the chloride. So on one side, you're going to get a precipitate, a solid, that's going to be your AgCl. And then on the other side, you're going to get your supernatant in your solution. That's going to be the copper 2+ and the bismuth 3+. So first off, we're going to kind of hang out on this side, focus on the silver. So if you see a solid precipitate, chances are you have silver already, but we can confirm it with some additional tests. So the first thing we can add is some ammonium in the form of ammonium hydroxide. And so when you add ammonium to silver, so you kind of have this AgCl as a solid plus some ammonia, it's going to form a coordination compound. And so it'll form this silver ammonia coordination compound. And this guy is soluble in water. So what you'll see is when we add the ammonia, our silver precipitate, our silver chloride, is going to disappear because it's forming this silver ammonia complex. And then we can actually reverse this reaction. So if we add some acid to this, in the form of, so let's see, when we add some ammonia, we'll reprecipitate or redissolve and get some silver ammonia complex. And then we're going to add more acid to this next step. And so if we think about NH3, that's a base. So when we add acid to it, it's going to form NH4+. And so this NH4+ cannot coordinate to this silver. And so what we end up getting is our silver chloride back and some ammonium, right? So we can see the solid come back. So you can see we can form a precipitate, get it to redissolve, and get it to come back out. And all of these are indicative of this silver being here. So just erase some of this stuff, move it out of the way. So then we can add some, I think, HNO3 to form our silver chloride back as a solid. So we'll form the solid, precipitate or redissolve it, and then reform the solid. All right, so off screen, I've taken some of our original solution and just put them in new test tubes. Again, we have the known and the unknown. Next up, we're going to add some 6 molar HCl to this, and we're going to keep going until precipitation stops. So let's go with the known first. You can see the precipitation occurring. You can see precipitate has definitely formed. Let's go ahead and do the same with the unknown. Think about the best way to do this. Here we go. So I'll give you guys a close-up here of this precipitation occurring. If it does. Yep, look at that. Definite precipitation occurring. It's hard to tell when it stops. So what we're going to do is centrifuge this, then we'll add some more HCl and see if all the precipitate has come out. All right, so off screen, as you can tell, I've gone ahead and centrifuged these two solutions. You can see all the solid is nice and stuck on the bottom. Next up, we're just going to add a little bit more HCl to make sure all of our precipitation is complete. So you can see no more precipitate being formed there. And no more precipitate being formed there. So our precipitation is indeed complete. Next up, I'm going to separate the solid and the liquid by decanting. Leave a little bit in there, that's okay. Then I'm going to wash my solid with some more water. So I'll just toss some more water in there. It's just like 5 drops. I'm just going to add it a little bit. About 5 drops. About 5 drops. Cool. Then I'm just going to re-centrifuge this and then combine the liquids and the solids, and I'll do that all off screen. All right, next up I've got my bits of solid. As you can see here, I've already decanted, already done all that stuff. So to confirm the presence of our ion, next thing we should be able to do is add some ammonium hydroxide, and we should be able to see this precipitate go away. So let's see how that goes. So if you take a look down the test tube, all of our precipitate is now gonzo. Do it with the other one. Again, what we're adding here is ammonium hydroxide. The best angle here is, it sucks. There we go, something like that. and you can tell all the precipitate is gone. So now upon the addition of acid, in this case 6 molar nitric acid, we should see our precipitate reappear. So you gotta be a little careful with this stuff. You're adding acid to a base, and so it's a little bit sketch. Let's go ahead and see what happens. Add very slowly, kind of drop-wise. And you can see our precipitate has reformed. And it's quite warm to the touch. Unknown, same thing. Let's add some acid. There it goes. So you can see the reappearance of our precipitate. Perfect. All right, so we've taken care of the silver, so all we have to worry about left is this copper and this bismuth, and we're going to work with this supernatant from this section right here. So to this supernatant, we're going to add some ammonium hydroxide. And this ammonium hydroxide is actually going to do kind of 2 different things. So let's take a look at each component. First, there's the kind of ammonia, and then there's the kind of hydroxide component. So let's see for each of them what they're going to do. Copper plus ammonia is going to form a coordination compound. And this coordination compound, as you'll see, is a deep blue. So if you see this deep blue, that means you have copper there. If you don't see this deep blue, then you don't have copper. So that's that part of the component. The second part of the component is this hydroxide. So bismuth plus some hydroxide will precipitate out some solid bismuth hydroxide. It's going to be a solid. So you'll see some solid forming in case bismuth is there. So let's focus first on the copper side of things. So let's see. The precipitate here will be bismuth hydroxide. And then the supernatant here will be your copper. So we can also do other tests to confirm that the copper is there. And so for the copper, another thing we can add is this potassium ferrocyanide. So we can first acidify the solution by adding some acetic acid, and then add some of this potassium ferrocyanide complex. Cool. And so upon reaction with this compound, move this out of the way. You will form some copper iron cyanide complex, and this is going to be kind of a very brick red color. So if you see this brick red, that confirms the presence of copper. All right, so we've got our supernatants from earlier, the known and the unknown. right? So next up, we're going to add some ammonium hydroxide, and this time what we're looking for is a deep blue formation, and possibly the formation of a precipitate. So let's check out what happens with the known. So I should get my blue glove out of the way. You can see some forming on the top. A little shake goes away. Add some more. You can see a nice deep blue with what actually looks to be a white precipitate. So a deep blue solution with a white precipitate. A little bit more, see if more comes out. Looks like it's pretty good there. So there's your known. Let's take a look at the unknown. Same thing, I think it's a pretty decent camera angle. So here we're seeing a blue solution, a deep blue solution. The camera's not picking it up the greatest. Like blue glove isn't a bad background. Yeah, you can see against the white lab coat there, it's quite blue, but this time no precipitate. So, you know, think about that. They're different, yet the same. All right, so off screen, I've gone ahead and centrifuged the solution. You can see in our known, we have the solid white precipitate, and this unknown, we do not have any precipitate. So we can't decant if we don't have a solid, so we're just going to decant the known into a new test tube to save for later. Actually, we're going to use the supernatant and keep the precipitate for later. Let's go ahead and just decant. And we'll save the precipitate for later. And we'll keep working with the two supernatants. Next up, we want to acidify the solutions with our glacial acetic acid. Let's see, just give you. Yeah. So it's basically just vinegar, super strong vinegar. You don't want to drink this stuff. Go ahead, start adding some. Check with our litmus paper, see if it's acidic. See, not acidic yet. Probably added a bit too much of the ammonium hydroxide, so it's going to take a little bit, but whatever. You can see the blue color's kind of going away. Probably means it's good enough. Yeah, you can see acidic. So let's go ahead and do the same thing for this other solution. So we'll just wait for this kind of deep blue to kind of go away. That seems to be an indication. Yep, acidic enough. Next up, we're going to add this potassium ferrocyanide and take a look for a red precipitate to form. Here it is. You can see it's kind of like this off-white yellow solution. Good camera angle. There it is. A little bit more just to make it look cool. That's pretty cool. There it is. That's the unknown. Let's see if I can get like a super close-up shot. That would be cool. Kind of missed it, but whatever. As you can see, this red precipitate is definitely forming in both of those. Cool. So we're done with that. Next up, we're going to move on to the precipitate. We're just going to use our known because our unknown didn't form a precipitate. All right, so that brick red corresponded to the copper. So the only thing we have kind of left to deal with here is this bismuth. So if you remember, it precipitated out. So we're at this bismuth hydroxide step. And so we just want to confirm that this solid is bismuth and not something else. So to this, we can add some freshly prepared tin hydroxide. And basically what this is going to do is it's going to act as a reductant. So if we have this kind of bismuth 3+ type of situation that we have here, and then we add some tin hydroxide, we can make it bismuth hydroxide. If we add some tin hydroxide to it, this will basically act as a reductant, and this will go from bismuth 3+ back to its elemental form. So bismuth 0, or just some solid bismuth, and this will look like a black precipitate. So again, what you're looking for here is a black precipitate, and that's indicative of the bismuth. And that's it. All right, so final test. Remember, our unknown didn't form a precipitate, so there's nothing really we can do there. So we'll just deal with the precipitate from the known. First up, we have to make our solution fresh. So we've got our stannous chloride right here, SnCl2. So we just need 2 drops of this into a new test tube. About 2 drops. 1, 2. And then we're going to add drops of sodium hydroxide until the precipitate just appears. Oops, okay, not disappears, appears, just, or disappears, yeah. So precipitate should form and then it should disappear. If I read that correctly. So we got our sodium hydroxide. Take this, see what happens. You see a precipitate forms almost immediately. Just keep adding until the precipitate disappears. Yep, so it's disappeared. Cool. So let's add this solution to our known. Hopefully I didn't mess this up. Let's check it out. Let's just pour it straight in. I don't have a long enough test tube or a pipette. And we can see here we have the formation of some kind of black precipitate. Think about what that means.